All right, so let's start talking about operations and decimals. So we're going to talk about the big four: adding, subtracting, multiplying, and dividing. And again, I assume that you guys know how to do this. I just want to talk about why it works. So adding and subtracting, there's nothing too much to say with this. Basically, because we've determined that decimal fractions behave the same as place value, everything just goes through quite easily. So you just line up your place values, your digits, and add right to left, carry to the next place if you need to. So we're just going to do that. Let's do a quick example just to make sure we get this. So let's find, I don't know, 53.071 subtract 6.29. So remember, when you're adding and subtracting, lining up your place values is very important. With multiplication and division, it's not going to be. So let's do it. 53.071. We're going to subtract 6.29. And I'm going to even add this 0 here, just so it's kind of easy to see what's going on. So I shouldn't even say in my mind, I'm actually doing this in the paper. I am adding a 0 so that the top and bottom have the same digits to the right. So we go up to the thousandths place to the right. Okay, now we subtract as normal. 1,000th minus 0,000th is 1,000th. 700ths minus 900ths, we don't have enough. We want to borrow from the tenths place, but we can't. So let's borrow from the ones place. We have 3 ones. We'll break up 1 1, leaving us with 2 ones, into 10 tenths. But remember, we need some hundredths, so let's break up 1 of those 10 tenths, leaving us with 9 tenths, into 10 hundredths. We have 7 hundredths, so 10 plus 7 is 17 hundredths. And we subtract. 17 minus 9 is 8 hundredths. 9 minus 2 is 7 tenths. We'll put our decimal place in here. 2 minus 6, well, this is just subtraction of whole numbers. We know exactly how to do this. Cross that out. So we have now 4 tens and 12 ones. 12 minus 6 is 6, and 4 minus 0 is 4. So nothing particularly special with adding and subtracting decimals. You just line up your place values and subtract or add as you need to, carry and borrow as appropriate. Let's move on. And let's talk about things that are a little more interesting. And again, we know how to do it. We just need to determine why it works. So let's do multiplication. So when we multiply, let's just do an example. And then let's talk about the steps. And then we'll talk about why the steps work. So let's do a quick example. Let's do, I don't know. What do we want to do? Let's do the same numbers. 53.071 multiplied by 6.29. So let's write this as one number over another number. So 53.071 and then 6.29. Notice I don't care where my decimal places are in this. So we just multiply like we do without decimals. And then there's a little bit of a rule at the end that we know. We add up the number of decimal places, and that's the number of decimal places in our answer. So let's go ahead and do it. So we multiply like there's no decimals. That's step 1. 9 times 1 is 9. 9 times 7 is 63. Carry your 6. 9 times 0 is 0 plus 6 is 6. 9 times 3 is 27. Carry your 2. And 9 times 5 is 45 plus 2 is 47. 2 times 1 is 2. 2 times 7 is 14. Carry your 1. 2 times 0 is 0 plus 1 is 1. 2 times 3 is 6. 2 times 5 is 10. All right, we'll go to the next place. 6 times 1 is 6. 6 times 7 is 42. Carry your 4. 6 times 0 is 0 plus 4 is 4. 6 times 3 is 18. Carry your 1. 6 times 5 is 30 plus 1 is 31. And now, just like before, we add our digits. 9. 3 plus 2 is 5. 6 plus 4 plus 6 is 16. 7 plus 1 plus 2 plus 1 is 11. Carry your 1. 7 plus 1 is 8. 6 plus 4 is 10, so this is 18. Carry your 1. 4 plus 1 is 5, plus 8 is 13. Carry your 1. 1 plus 1 plus 1 is 3. And we have a 3 here. So, the next thing we do, and I think this was on the skills test, so most people know this rule. You count the number of decimal places in both numbers. And add. This is the number of decimal places in your answer. Okay. So here we have 1, 2, 3 decimal places in the top number. 1, 2, 2 decimal places in the bottom number. 3 plus 2 is 5. So 1, 2, 3, 4, 5. So our decimal place goes there. And that kind of makes sense. I always like to estimate when I'm doing these things. So I have 50 times 6, roughly. 50 times 6 is 300. So even if I didn't know this rule, I would just put where the decimal where it makes the number closest to my estimate, which is 300. So 333.81659 is our answer. Now, nothing special there. That was just a little reminder of how to multiply decimals. But the question is, and this is the important bit, is why does this work? Well, there's nothing fancy about this, but it all comes down to the fact that we were talking about in the previous video. Well, we can think of decimals, if you like, as decimal fractions. So, what did I do here? There we go. We can think of this guy, 53.071, as a decimal fraction, say, over 1,000, and 6.29 as a decimal fraction over 100. So, let's do it, and then we'll talk about what's going on. So, if we didn't know anything about decimals, but we knew how to convert decimals to decimal fractions, we could do that and then multiply because we know how to multiply fractions. So, 53.071, we know that's 53,071 thousandths. And we know that 6.29 is the same as 629 hundredths. So they mean the same thing. Now we want to multiply these fractions, and we know exactly how to do that because we know how to multiply fractions. It's very easy. Multiply your numerators, multiply your denominators. So let's go ahead and do that. So 53,071 over 1,000 times 629 over 100. Well, I'm going to multiply my numerators first, so that is 53,071 times 629 over, now I'm going to multiply my denominators, 1,000, or maybe I'll even write it like this. Bear with me, this is probably a little bit better. 1,000 is the same as 10 to the 3. 10 times 10 times 10, a 1 with 3 zeros after it. And 100 is 10 to the power of 2. So that is a 1 with 2 zeros after it. So if we think about what's going on here, well, what's the numerator? The numerator, we're multiplying 53,071 by 629. And what are we doing? We're multiplying the numbers like the decimal places aren't there. So we know the answer for this. The answer for this is 333,81659. We just did that. I'll put in some commas so it's a little bit easier to read. 33,381,659. And we know how to multiply numbers with the same base with different exponents. So this is going to be 10 to the 3 plus 2, which is 10 to the 5. And you can see what's going on here. Let me scroll back up. So part 1, we multiplied like there were no decimals. This is really just multiplying the numerators. So that's what we're doing in part 1. We're multiplying the numerators of our decimal fractions. And when we count the number of decimal places, add them together, and then count over in our answer like we did here, this is like multiplying our denominators. So this is multiplying denominators. So what did we do? We turned a problem that we just kind of knew because somebody told us how to multiply decimals. We turned that into something where we did know how to multiply and we did know why it was true. We talked about why we could multiply fractions the way we did a few lectures ago. So now using that knowledge, we came up with a reason why we multiply decimals the way we do. So this is good. This is another operation. Now not only do you know how to do it, you know why it works, why we do multiply decimals the way we do. And the last operation we're going to talk about, of course, is division. So, division's going to be not too bad. Let me just give you a reminder first of multiplying and dividing by powers of 10. So things like 10, 100, 1,000, whatever. So if I had something like 4.2 and I multiplied it by 10 squared by 100, I move that decimal place over 2 places to the right to make the number bigger. So my answer is 420. So I moved it from 4.2 all the way over to make 420. Well, if I divide by 100, so divide by 10 squared, then I'm going to move the decimal place 2 places to the left. So this becomes 0.042. So I started at 4.2 and I moved it 2 places to the left. So that's just a little reminder. I don't want to talk too much about that. We all know how to multiply and divide by powers of 10 and why that works. But just a little reminder because it's going to be important to us. So let's do a little division problem and then we'll talk about what we do and why it works. So let's do the following. Let's do 3.24 divided by 0.618. So what we do is we write this as 0.618. That's our divisor. So that goes outside our division symbol. And we put the 3.24 underneath. Our dividend goes underneath. And we want to move the decimal place in the divisor over until there are no more decimals in the number. So we move it 3 places to the right. And because we did it in the divisor, we have to do it 1, 2, 3. We have to do it in the dividend as well. So we get the problem 618 divided by 3,240. We move our decimal place from 3.24 all the way over 1, 2, 3 spots to get 3,240. Now we just do long division as we usually do. We all know how to do long division. I'm just going to leave it there. We don't need to worry about the answer right now. But hopefully you guys remember how to set up long division problems where you have a decimal in the divisor. So let me write down what we did. Move the decimal place the same number of places in the dividend and divisor so that the divisor is a whole number. So that's what we do. And again, we care about why this works. And the reason isn't too complicated. Again, it has to do with decimal fractions. So we have let's write down why does this work first. So why does this work? Well, 3.24 divided by 0.618, I can write as decimal fractions. So 324 over 100 divided by 618 over 1,000. Remember, if we look here, the hundredths place is the smallest place value for this number, so our denominator is 100. The thousandths place is the smallest place value for our second number, for our divisor, so the denominator is 1,000. And I'll write this and you'll see why in a second. I'm going to write this as a fraction divided by another fraction, just so you can see what's happening here. So this is 324 over 100 divided by, so a fraction of fractions, 618 over 1,000. I know this looks kind of weird, but it still makes sense. So what we want to do is we want to convert this to a problem where the divisor has no fraction down here. Then we can do long division however we like up here. So let's go ahead. So what I can do is I can say, well, I know the idea of equivalent fractions. So what I'm going to do is I'm going to multiply top and bottom of my fraction by 1,000. And that'll get rid of that denominator. So this becomes, well, let's actually do some cancellation. 1,000 divided by 100. 100 divided by 100 is 1. 1,000 but divided by 100 is 10. And then 1,000 divided by 1,000 is, of course, 1 in both cases. That's why we multiply top and bottom by 100. So this becomes 324 times 10 is 3,240. And we just have 618 in our denominator. So these problems, notice there's equal signs all the way through. They're the same thing. So when we do move the decimal place in the divisor and dividend, we're really using the idea of equivalent fractions. We could write it in terms of decimals in our fractions as well. It might be a little bit easier to see. So let's just do it one other way. So this is the same thing as 3.24 divided by 0.618. Remember, when you write decimals when you're writing decimals, you're thinking of them as decimal fractions. These guys, 3.24 and 324 over 100, are literally the same thing, just written a little bit differently. And then we can multiply top and bottom by whatever it takes to get a whole number in our denominator. So 3.24 times 1,000, we move the decimal place over 3 places, and we get, of course, 3,240. And 0.618, we need to move the decimal place over 3 places, so we get 618. So it's the same thing. So when we do long division with decimals and we move the decimal place over, what is going on? Nope. I want to scroll the screen. That will not let me scroll the screen. That won't let me scroll the screen. I don't know what's going on here. Nope. Everything. I guess I can't scroll the screen. I'll just point at what I need to. So, whenever we're doing long division with decimals, and we convert it into a problem where the divisor doesn't have a decimal, all we're doing is using the idea of equivalent fractions to come up with a fraction where we know how to divide, because we know the divisor doesn't have a decimal in it. So I'll quickly just do a reminder example for you guys. Let's do something along the lines of let's do 0.0014 divided by 0.006. 6. That will do. So we write it with, of course, the divisor on the outside and the dividend under. We'll move the decimal place over 2 places. So this becomes 6 divided by 0.14. And just to make sure, when we do long division, we talked about this before, but we need to keep our place values aligned. So I'm going to put my decimal there just to make sure we understand what's happening. Now we do long division like we usually do. How many groups of 6 ones can we make with 0 ones? Of course, we can make 0 groups. We've used 0 ones to do that. We have 0 left over. We bring down our tenth. We have 1/10. We can still make 0 groups. We've used 0 tenths. So we have 1/10 left over. We break it up. We look at hundredths now. So now we have 14 hundredths. How many hundredths? How many groups of 6 hundredths can I make with 14 hundredths? I can make 2 groups. And we've used 6 times 2 is 12 hundredths to make those groups. We have 2 hundredths left over. Let's do a couple more decimal places. So we'll break up our hundredths into thousandths. We can keep going if we like. We can make 3 groups of 6 thousandths using 18 thousandths, leaving us with 2 thousandths. Break it up into 10 thousandths, and look at this, it's kind of the same thing. We get another 20, we know exactly what's going to happen, we group it, we make 3 groups, we subtract 18, we keep going, we have 2 left over, we go to the next place, we bring it down. So now this is our, what is this? This is tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So we can still make 3 groups of 100 thousandths, and we're using 100 thousandths to do that, 200 thousandths left over, and the process continues. So we can write this, if you like, as our answer of 0. Oh, maybe I'll write it up here, actually. We can write it up here as 0.02, and then the 3 repeats forever, so we'll put a 3, and I'll put a line over it to say that that's the bit that repeats to the right forever. So that's how to do long division with decimals, of course, but I do want to point out, you notice this repeating pattern happening with this division. It turns out that unless it stops, you always get a repeating pattern. So when you do any sort of division of decimals or of whole numbers, then we will always get either a terminating decimal where it ends, or we'll get a repeating pattern. So the next lectures that we'll talk about will determine when. I'll show you that we'll only get both, and I'll show you when we get either type.